to this, but it'll be out there. Thank you for that. So for the things that I'm going to talk about, you really need to be under dark skies. I was out observing with my 5-inch refractor, the old 1970s one last night, and boy, I could hardly see anything, and it was a relatively clear night in the beginning. So for some of these things, you're not going to see them from your side yard, sadly. So you have to be under really dark skies, which means probably Custer Institute or Orient. I'm not sure about where Carl goes on the South Shore. Is he on the beach, West Hampton Beach, or is he on the
Yeah, Dune Road.
Dune Road?
Yeah, it's west of Poncog Bridge. It's called K Road.
Oh, okay. And is that, so he's on the ocean, not on the bay?
Correct.
Okay.
Well, both, but because Dune Road's narrow, but yes.
Yeah, okay. So Custer or Orient or maybe Dune Road or upstate, the Ashokan Reservoir or Cherry Springs. Probably at Orient, there's some, stuff there. Anyhow, dark skies. And the objects that I'm showing, and I'm only showing a few. I was going to show like a bunch, you'll see. Do not include double stars, and I didn't include planetary nebulae, just because for beginners, they're awfully tiny and very hard to find unless you have some go-to setup. So there's a lot of interesting things up there. If you love double stars or variable stars, there's a lot of them up there now this time of year. And so the objects that I'm showing are just a few of my favorites. So it's not a complete list at all. And then the legal part, my opinions are my own and not endorsed by Vanderbilt or Dave Bush. Sorry, I just had to say that. Okay, let's see. Now all I have to do is share my screen. Okay, share. And I want to do this. Last night, I went out after supper. There was still light in the sky, and it was such a beautiful crescent moon, which is really overexposed here. And then, of course, Jupiter, and then Aldebaran down below Jupiter to the left. And you should take note of my broken TV antenna, which is still on the roof of the house. It's not connected to anything, but it does make for an interesting foreground object. Oh, here's the cool thing. I'm probably at home, you can see this, and maybe here. Notice that the crescent moon is right over the top of the Pleiades. I was unaware of that. I thought, what are those few little white dots there? So that was kind of a cool thing. So I got some nice pictures last night. So April skies. And I'm going to read some stuff to you. I'm not sure how he's. Wow. No, I was just trying to figure out, do you want to try and make the thing on the side go away? So just to give you a sense of what we're going to be covering tonight, these are all the constellations. Well, I'll be talking about each and every one of these. And there's only 16 that I'm going to talk about. And average of 5 objects in each constellation. I'm going to discuss that in detail. So that's 80 slides, and we'll be done before you know it. So here's a great observing guide for beginners and for those who want a number of objects in one night. Discover the Stars by Richard Berry. He was a former editor of Astronomy magazine, and this is to show that the book underneath has a lot more information. Wait, why a book? We all have our iPhones and our iPads. We don't need no stinking books. So here's a display on my iPhone of the Milky Way in Sagittarius. So here's all these things that we can look at. A lot of them are globular clusters and open clusters. But the problem is, what do you look at? Do you just start picking some of them and seeing what you get? And so, certainly for the beginner, you're better off with a printed book like this. And I'll show you some of the details that Richard Berry includes. There are 12 maps like this, one for each month, so you don't need to have a planisphere. You can look at that, see what's up, what's down. At just out of the picture, it tells you this is the night sky, April 1 on a date, April 15 on a date, end of April, May, so on. So that's helpful. Just quick look for what's going on. So here's the April sky, and I'll read you this. The thing that I love about this, for me, there's an emotional part, a poetic part about looking at the night sky. I like the science too, but there's something, the night sky is powerful and it's poetic. So love what he does. As the stars of winter set in the west, the constellations of spring rise high. Overhead stalk two powerful beasts, the great bear and the lion, while in the south, the crow and the goblet ride the back of the twisting serpent. Leo reposes with his head high and hind legs tucked under. The lion's head and mane are made up of an arc of stars called the sickle. The bright star Regulus marks his heart. So I appreciate that. So what are there to observe if you're new to this? And Richard Berry does a nice job with this. Double stars. There's a whole section on measuring the sky, measurements, angles, using your hand to figure angles between things. Double stars is something that some people like to observe. Star clusters, and at the bottom he has these lovely little drawings. What's nice about the drawings is they're done in moderate sized telescopes, maybe a 3-inch, 4-inch, 6-inch telescope. Um, not something done with a 10 or 18-inch telescope. So you get a little bit of a sense of what the objects you're looking for are. I remember when I first started observing, I spent 45 minutes one night trying to find a planetary nebula. And what I didn't understand was you need a low power eyepiece to find it, but it looks in low power just like another star, and you can only find it with a high powered eyepiece. And of course, with a high powered eyepiece, the field of vision is so small that it's nearly impossible to find it using that eyepiece. Then he talks about nebulae, dark nebulae, emission nebulae. And here's the wonderful part. On the left is an emission nebula, a planetary nebula in the center, and a galaxy on the right. And what's nice is, he's showing what the galaxy is going to look like in your 4-inch, 6-inch, 8-inch telescope, and that it's going to be a small thing, but at least you have a sense when you're beginning, what am I looking for? How big are these things? And then uh, the Great Bear is full of distant galaxies. The best two form a pair above the bear's head, about where his ears might be. M81 is a 7th magnitude spiral, a nice oval fuzzball. Across the low power field, you'll see M82, smaller and elongated. M82 is an abnormal galaxy that emits powerful radio waves. Way off at the bear's other end is M101, a face-on spiral. Binoculars and low-power telescopes offer the best views because M01 is big. And here's where the book really pays off, because if you look at a map, which I'll show you, meanwhile, there's a galaxy 108 and a planetary nebula side by side right under the bowl of the Big Dipper. M108 is smaller and dimmer than the galaxies we've already looked at and quite elongated. The Owl Nebula M97 is small and round. The Owl and M108 are quite a challenge to new observers. Well, that's kind of cool to know before you go out looking and you say, I can't find it, I must have failed. And well, maybe not. It's a difficult thing to see. So then there are 21 maps in the last third of the book, and they show two or three constellations in each map. Um, so here is M81 and 82 down here. It's a little tricky to find. Um, I go from this star to this star and then bend a little and go about the same distance down to here and sort of noodle around, and that's how I find it. This is 97 and 98, which are very difficult to find. Um, So then opposite that star chart is a um, text page, and it talks about Leo the lion, a harbinger of spring. Leo rises as the bright constellations of winter set. Though it's not correctly placed in the stick figure lion, Regulus is said to mark his heart. Um, Leo hosts several noteworthy galaxies. Below the hindquarters of the lion is M65 and 66. I'll come back to this. And then there's NGC 3628, and then they talk about M95, 96, and M105. So I will come back to that, but he gives you a sense sort of what's interesting to look at. He's not telling you everything that's there, but he does take the time to talk about variable stars, multiple stars, and so on. And here's Leo, and I'll show you a close-up of that. So they're talking about there's two galaxies here. Actually, there's three, and then there's three here. And we'll talk about that some more. One of the things that's amazing at this time of year is the Virgo cluster here, which is in reality about 2,000 galaxies. What we can see is only a small subset of that. But if you're doing a Messier marathon, I'm not sure what the number is, but I think there's like 15 galaxies that you're supposed to find if you're doing a Messier marathon, and they're in here. So I'm going to head out first chance I get, probably not till next month now, and try a long exposure photograph with a camera on a tracking mount. And I was doing some calculations, and I think the answer was this was something like 9 degrees. So the crazy thing is, I thought I'd need a 300 millimeter lens on a full frame camera or 200. And the answer is probably a 105 or 85 millimeter lens to take in a large enough area. And I'd like to do multiple exposures and see what I can find. A little word about telescope performance. This is a page from All About Telescopes. It was published by Edmund Scientific, I think back in the 60s or before. There's a lot of stuff in here, but objective size here, 3, 4, all the way up to 10 inch. And then I sort of simplified it. So they list over here the faintest star. So the faintest star under really good conditions is, in a 3-inch instrument, is about 11, magnitude 11. A 4-inch gets you 11.8. So it's only like 0.6 magnitude 4 for the larger instrument. So here's what's amazing. 11.2 for a 3-inch instrument. If you come to a 6-inch instrument, you're talking 12.7. So that's a gain of 1 magnitude. So you're thinking, you know what, I own a 6-inch scope. I want to get an 8-inch scope. You only go from 12.7 to 13.3. And in fact, if you have a 6-inch scope and want to see 1 magnitude fainter, you've got to jump to a 10-inch scope. So it's interesting for one more magnitude, you end up with a larger, heavier, bigger telescope. Um, it's surprising. You would think that there would be a much larger improvement in your ability to see faint objects if you went from a 6 to a 10. Um, yes, 2.5 times. Right. Um, it is interesting that years ago I brought a 6-inch telescope to Stellafane and a 10-inch, and I was surprised that it, there was more detail in the 10, but I could still see things in the 6 that I could see them faintly that I could see in the 10. Um, the other thing is they're talking about faintest star. So if they say a galaxy is 10th magnitude, what that means essentially is you take all the light from that galaxy and condense it. I hope I'm right here. And when you can, this faint galaxy and you squash it all together, that's the same as a 10th magnitude star. So in fact, a 10th magnitude galaxy is much fainter than a 10th magnitude star. That's why Dave and the Vanderbilt are not responsible for what I say here. Okay, so some of my favorites. Um, M81 and 82 are two galaxies that you can see together in a wide field eyepiece. I'll never forget when I bought a 10-inch telescope, and I was in my backyard in Seacliff, and I used a wide angle eyepiece, and you can see the two galaxies together in the same eyepiece field. And I'll never forget that. It was like one galaxy would be awesome, but two in the same eyepiece field. And that was such a cool thing to see. I'll never forget the first time I saw that. And as I mentioned before, you sort of go from here to here and then out a little bit and bend it a little bit. There's nothing else more specific. And by the time you get this far out, the Telrad circles don't have much relationship to the stars in the bowl of the Big Dipper. So this is more than you're going to see in your telescope. Maybe if you went back to the front door and looked at it. But they're really cool because one of these is more edge on than the other. And if you look at this from a long way away, you can see both of them. They're faint, but it's such a magnificent thing to see. The other thing that's a huge favorite for me is M51, which is a galaxy, but it's actually two galaxies, and one galaxy is eating the other. Interestingly enough, it's in Canis Venatici, but I always find it using the Big Dipper. So you go out the handle of the Big Dipper and come down here to Alcade, and then this circle, I don't know if that's not it's like 3 degrees. If you put a Telrad um, on a sky chart on your computer, the Telrad, the outer ring, will be about here, just outside that. So you put the Telrad and the ring comes here. So it's like, there's 4 degrees, 2 degrees, and 1 degrees. So the 4-degree circle is here and the 2-degree circle is here. So it's, you take the widest Telrad circle and move it about 1 width away from Alcade, and you're liable to find yourself right on M51. It is in Canis Venatici, but we use Ursa Major to find it. Oh, I'm sorry. That's another talk. It's a big, black, ugly thing that when you first get a telescope, in no way do you want to put that on top of your telescope, but it's a wonderful device for looking at things. Maybe some of you are familiar with the little bullseye pointer that comes with a lot of telescopes, and you look in it and there's a red dot projected against the sky, and you go put the red dot where you think the thing is. The advantage of the Telrad is that because it has large rings, a large ring, a smaller ring, and a tiny ring, it's 4 degrees on the outside, and you can use that if you know something is 8 degrees away, or it's big enough so that you can make geometrical comparisons on a star chart on your computer and at the telescope. So the red dot is out there, but if you say I need to be a certain number of degrees, the red dot is of no help. One time I saw this sort of like this, only much fainter. I have a friend who worked at Kitt Peak, and they have a 24-inch Newtonian telescope in the visitor center. So after visiting shut down, my friend Stan Honda and I were out there visiting my friend, and we went up to this 24-inch Newtonian at the high altitude of Kitt Peak on really dark skies. And I have never seen M51. Imagine this so much fainter, but that you could see so much of this detail. It was like absolutely a thrill. The story with this is the larger galaxy is pulling material off the smaller galaxy, and you can see the path of how the material is pulled into the center of the larger one. I can see this at Stellafane on a good night and see both central bright spots and sometimes faint hints of the line that joins the two. So once again, you need a really dark sky to do that. And that's with an 8-inch telescope. So it's something you can see. So now we'll come to Leo. And there are 2 galaxies here. And I'm going to jump to another. And here are 3 galaxies over there. We'll go back. And what's interesting is I had forgotten, I'm sorry. So this is called the Leo Trio, Messier 95, 96, and 105. And I was out at Custer on a dark night, and I was looking at this, and there's a 3rd galaxy in here. It's an NGC galaxy. And it's 3 galaxies, and the 3 of these look as good as the other 3 that are called the Leo Trio. And when I got home, I had to check and see which was the Leo Trio, because there were 2 sets of 3 galaxies. So this is 66, 65, and 36, 28. And, guess what? It's 3 galaxies, and they all show up. I think I was using an 8 or 10-inch scope, but it was a dark night out at Custer. It probably doesn't get quite that dark anymore. And then here's 105, 96, 95, and 96. And here's 96, 95, and 105. So they're in a different arrangement of geometrically, but it's still 3 galaxies. And the last one, this isn't the best time to look for it. The best time to look at this, it's Auriga, was a month or 2 ago, but it's still in the sky going down in the west. And this was one of the first things I looked at when I got my first telescope. And one of the cool things about it is that there are 3 open clusters. You can see they're circled here, M37, 36, and 38. And the cool thing is they're all in one object, so you don't have to go far to compare them. And I'm sorry, wait a minute. How did I do? Okay. Um, so this is what Richard Berry says. Auriga lies in a starry region of the Milky Way, renowned for its trio of sparkling star clusters, M36, 37, and 38. Auriga is worth scanning with binoculars or a telescope for no more than the pleasure of seeing so many stars in the field. Like, how cool is that to know? It's like, no, I'm going there just to see that thing. And he's saying, no, no, take note of all the stars in the field because it's in the Milky Way. Of the three clusters, M37 is the brightest, then comes M36, and last M38. All are easily located with binoculars. With a telescope, they are interesting objects to compare. And that's what's cool about this because the three of them are really close. I've gone out and compared globular clusters, and I'm jumping all over the sky, and here's three of them that are different, right close to one another. M37 is one of the finest clusters in the sky. It lies in a rich starry field and consists of a uniform sprinkling of several hundred stars. M36 has fewer stars and is more concentrated toward the center. The stars of M38 are spread out, and it looks dimmer than the other two and irregular in shape. So, there's a curious thing too, that when you photograph something, I didn't understand when I first started astronomy and I was getting Astronomy Magazine and Science, Sky and Telescope. They had all these drawings, and I thought, drawings? What are you? Come on, it's high tech, there are cameras and film and all of that stuff. Why would anybody draw anything? And I came to discover that the drawings are liable to look more like what you will see with your eye than a photograph will. And parts of that are because the brighter stars in a long exposure that it takes to get these images, the brighter stars will get a lot brighter. And in sketching, that doesn't happen because the artist is drawing what they see with their eye. So this may be the best example of why these three are fun to look at. 37 down at the bottom is the first one you come to, which is sort of fainter stars. And then 36 has a mix of fainter, brighter, and then there's 38. I've spent a lot of time going back and forth. It's really fun to do. And I think sometimes we learn more instead of just randomly looking at clusters, to spend some time to compare them. Like, how are they different? How many stars are in this one, in that one? Barry's book does a good job of explaining what open clusters are easiest to see, especially if you're a beginner. Oh, okay. Oh, yeah, right there. Yeah. Good point. Thank you. Really? Yeah, okay. So remember these, and then here are photographs. This is 37 in a photograph. And you can see that, just to not to beat this to death, but here's 37. And notice what it looks like. You can see quite a difference between lighter stars, medium stars, and brighter stars. And then once you photograph it, there's like two kinds of stars. But anyhow, worth looking at. So that's 37. There's 36. And there's 38. So I find that trains my eye better, to take the time to compare similar things. And maybe you'll want to check globular clusters, or you may start going and looking for planetary nebulae, because there's vast differences in how they look. I'm done.